We'll now look at a method for solving systems of equations called elimination. And this will have 5 steps. The first step is to multiply one or both of our equations by a non-zero constant. The idea is we want to have a term in the first equation that's something like 2x and the second equation has negative 2x. Or maybe the first equation can say negative 5y and the second says 5y. We want these additive inverses as our coefficients. We can then add those equations to eliminate a variable. And this is why we wanted the additive inverse coefficients, so that when we added, we got rid of a variable. We then solve the resulting equation that we've got from step 2. We'll then use this equation, or this step 3, to find the remaining variable in step 4. And then finally, step 5, we want to check the solution. Here we can see a system of equations. And like I said, we're looking for additive inverse coefficients on one of our variables. And we already have that here. So we actually get to skip the first step and just add these up. 3x plus 2x is 5x. 2 minus 2 is 0. And then on the right-hand side, 12 minus 2 is 10. Dividing by 5 gives that x is equal to 2. To find our other variable, we pick either one of the original equations and substitute in what we know. I'm going to do the first equation. So we have 3 times x, which is 2, plus 2y is equal to 12. This gives us 6 plus 2y is equal to 12. We can subtract 6 to get that 2y is equal to 6, and then divide by 2 to get that y is equal to 3. So our solution is 2, 3. Here's another one, and we see that if we add up these two, nothing will cancel the way it did on the last example. So we'll actually have to multiply through by something. What we multiply through by really depends on what letter we want to eliminate first. In this case, I'm going to eliminate the letter x. I personally prefer if one of the terms is already positive and the other one's already negative in our original equations. And we see that with the x. We have a positive 3x and a negative 1y. And we need to make them both cancel. And I can do that by multiplying the second one by 3. So my top equation will stay exactly the same. And then on the bottom, negative 3x plus 3y is equal to 15. Now when we add them up, the x's cancel. I'm left with 7y equal to 28. Dividing through by 7 gives me that y is equal to 4. We need to use one of our equations to solve for x. It doesn't matter which one. We'll go ahead and use the second one. Negative x plus y, which is 4, is equal to 5. We can subtract 4 from both sides to get that negative x is equal to 1, which tells us that x is negative 1. So my solution, negative 1, 4. Our next system, once again, we can see that nothing cancels naturally, so we're going to have to multiply through by something. I'm going to try to cancel the y's because, once again, I like it when something is already positive and negative. In this case, we can't multiply just one equation because 4 times a nice whole number is not equal to 5, and 5 times a nice whole number is not equal to 4. We could try multiplying through by a fraction, but that's not very helpful. I'm going to multiply the first equation by 5 to get 10x plus 20y equal to negative 8, or negative 10 rather. And then we'll multiply the second equation by 4 to get 12x minus 20y equal to negative 56. Now when I add them, I get 22x equal to negative 66. Dividing by 22 tells me that x is negative 3. I can then use either of my two equations to find y. We'll use the first this time. 2 times x, which is negative 3, plus 4y is equal to negative 2. This says negative 6 plus 4y equal to negative 2. We can add 6, which tells us that 4y is equal to 4. And then dividing both sides by 4 tells us that y is equal to 1. So in this case, our solution is negative 3, 1. Next, we'll look at this one. We don't have one positive and one negative number in this case, so we're going to have to just pick one of our variables to eliminate. Ultimately, it won't matter which one, you'll end up with the same answer in the end. So we'll do x. In that case, I'm going to multiply the first equation by 3 to get 6x plus 12y is equal to 6. For the second equation, I'm going to need a negative 6, so we'll multiply by negative 2 to get minus 6x minus 12y equal to minus 6. And when we try to work this out, the x's cancel, but in this case, so do the y's, so that I have a 0 on the left. And on the right, I also have a 0. So if we want to know what the solution to this one is, there are actually infinite solutions. And this is a very strange concept, but essentially, if I try to graph these two equations, they actually lie along the same line. So all of their points are actually in common. The way we usually write this is to pick either one of the equations and solve for either one of the variables. It doesn't matter which equation you pick or which variable you solve for. I picked the first equation and solved for x and got that x is equal to 1 minus 2y. So when we write our solution, x is 1 minus 2y, and then y, we just write a y. Essentially, this gives us a format for our solutions. If you give me a value for y, I can tell you what x needs to be to make it an actual solution. For our last one, last time we tried to eliminate x, so this time let's try to eliminate y. I can do that by trying to multiply the first equation by negative 2. That would give me negative 6x minus 4y equal to negative 8. And I'm going to leave my second equation alone since it already has the plus 4y. When I add them, once again my x's cancel and my y so that I have a 0 on the left. And on the right I have a negative 3. And if I think about when is 0 equal to negative 3, well, that never happens. This actually has no solution. If I tried to graph these two equations, they would be two parallel lines. They never intersect, and therefore they don't have any points in common.